So I'm trying to create another example of one of these queue and stack data types. So I'm looking for queues, an example where I've seen queues used well. And this is FileZilla, a file transfer protocol program for uploading data to, say, a server. And this is what's interesting about this is it lets you, when you try to upload a file, put it into a queue. And the idea is that it takes a while for files to get uploaded, and it's not time that your CPU is busy, it's time that you spend waiting to read data from a disk or waiting to see if the data made it up to the server correctly. And you wouldn't want one process to just be sitting there waiting all of the time. So what you do is you can have multiple processes going on concurrently in parallel. So that way when one process is stuck waiting, then the other process can take over the CPU and do a bunch of work until it has to wait. And so you can have multiple workers all operating on this same queue, trying to process them in the same order that I asked for them to be uploaded. But in case one of them has to delay, we just try to maximize the throughput anyway. So I need some files to upload. And in order to generate those files to upload, I'm going to write a quick little Python program. I'm in the temp directory in C:, and I'm going to make a loop that takes a variable I through maybe 100 different values. And for each value of I, I'm going to open a file, and the name of that file will be called F, and I'm going to pad with maybe 3 zeros and I'm going to print I. So it'll be F000 with 3 zeros, F with, actually I plus 1, so I start counting from 1. So it'll be F001 through F09, from F100 at the end. Okay, so that's just going to generate some file names using the string.format command, and I want to be writing to those files, and I'm going to call that file that I open F. And once I've opened that file, I'm going to say f.write, and I'm just going to put data in there. I'll write I as a string, and since it's a string, if I multiply it by a number, it'll repeat it that many times. So I will write it a million times. That'll be a pretty good size file. And there we go. So if I hit enter and enter again, it does all that. So now I come over here, and if I refresh the display, I have a bunch of reasonably big files numbered from 1 to 100 here. And it's good because if I just try to add these to a queue to get uploaded, they'll get added in order based off of that number. So if I just add those files to the upload queue, they're added in that order. Now we're not processing the queue yet, they were just put into a queue. And if I tell it that I want to just always be processing things in the queue, what should happen is, let me try to make this bigger so we can see what goes on. It should create 7 processes. And so we should see 7 different progress bars showing up here as these things go up. But it should process them in the same order they were added to the queue. So it should start with 1 and then 2 and then 3 and 4 and try to process them all in the same order. So here we see all of those processes are connected. Let me kind of try to fit that in the screen. They're uploading. These first 7, because I have 7 workers, are being processed in parallel. And you see some of them are ahead of others, but we're trying to pretty much do them in order. And so while one of them is stuck waiting, the other one can be uploading in parallel. This gets the most usage out of your CPU, and it maximizes your throughput. Each individual file still uploads slowly, and yet overall we're 7 times as fast because we don't spend as much time waiting. If I look at my CPU usage, let me see if I can do that. Performance. Yeah, I can see that I'm barely touching the amount of CPU usage I could have gotten out of this. The bottleneck appears to be something else. So um, yeah, so you can kind of tweak that in order to get the most performance, but this is another example of how a queue is used to manage the way that you work concurrently. So you can produce a lot of work, and then you have a bunch of workers that kind of bring those tasks out of the queue and do them.